Level Avenue Design presents the battery assembly system.
In this demonstration, we will navigate through the process of assembling the system and its components.
The backbone of the system are its 7 laser-cut acrylic panels, comprising of a 1/8 thick center panel and 6 panels at 1/4 thickness, 2 inner panels, 2 outer panels, and 2 cover panels. Its power comes from 280 flat top, 18,650 type battery cells that are connected through 22 waterjet cut and pressed bent spring copper contact plates, comprising of 1 positive contact plate, 1 negative contact plate, 1 tabless contact bridge plate, 1 tabbed contact bridge plate, 8 inner contact plates, 5 right tabbed outside contact plates, and 5 left tabbed outside contact plates. It all ties together through 292 sourced components, comprising of 4 aluminum conducting spacers, 40 standoffs, 40 steel rods, 81-inch nylon spacers, 40 lock washers, 40 aluminum hex nuts, 24 3/4 nylon hex head screws, and 24 nylon hex nuts. The charge and discharge operations are governed by a sourced 72 volts, 80 amp battery management system, seamlessly integrated into the acrylic panels with 4 precision tabs. The only tool required for assembly of the structure is a generic standalone socket, matching the screws. We start out with the 2 acrylic inner panels laid on top of the outer panels and proceed to install 20 standoffs on one of the inner acrylic panels, followed by laying 6 of the inner copper contact plates in their specific orientation. Moving to the second inner panel, an additional 20 standoffs take their place and are covered by the acrylic center panel. The demonstration involves a partial disassembly to allow access for the installation of specific components before the final reassembly. Tightly holding these panels together, we flip them as we're about to introduce steel rods and nylon spacers. The outer panel takes its place as rods pass through dedicated holes. Contact plates and lock washers take a back seat at this provisional stage. The cover panel follows before 20 hex nuts are threaded onto the rods. After setting aside the assembled section, the acrylic center panel has 4 aluminum conductive spacers installed into it. These will conductively bridge the 2 sides of the unit. The remaining inner contact plates are laid. The assembled section is carefully positioned, and nylon screws are placed through the top and bottom holes of the contact plates. The assembly is stood vertically in nylon hex nuts. Lock the plates in place. We bring the outer acrylic panel back. As the assembly is laid down, aluminum hex nuts, acrylic cover panel, outer panel, nylon spacers, and steel rods step aside for the installation of remaining nylon screws. We pair the remaining nylon hex nuts and proceed to tighten them with our trusty hex socket. We lay the core section down as rods, nylon spacers, outer panel, cover panel, and hex nuts take their place once again. Same goes for the other side. Rods, nylon spacers, outer panel, cover panel, and just a couple of hex nuts will do for now. The battery management system takes its place. We remove the top hex nut to allow some playroom during installation. and restore that hex nut back in its place. We then drill a hole for securing the assembly's negative contact and another on the output side. The unit is laid down for the next phase. We remove the aluminum hex nuts, set the cover panel aside, and reinstall a couple of hex nuts, keeping everything else together. Now for the power source, we'll need the 280 equally charged battery cells. They are unpacked and labels are peeled away before use, ensuring a perfect fit. Each cell is installed with its positive and negative sides carefully oriented. 2 cells are installed simultaneously to ensure mutual support. A nuanced design decision, ensuring a structurally robust yet compact unit. We remove the 2 hex nuts, install 5 identical outer copper contact plates, cover panel, and introduce lock washers before hex nuts are installed and tightened one last time. This process is repeated for the other side of the unit. A screw secures the assembly's contact plate to the battery management system, facilitated here by pliers and a small electric screwdriver. Each copper contact plate features a tab dedicated to balance wires for the battery management system. With the exception of one bridge contact plate, installing the main output cables may be easier with a little assistance. Tabs on main positive and negative copper contact plates have been implemented for a diagnostics purposed voltmeter. The final step involves plugging the balance wires into the battery management system, completing the assembly and bringing it to life. The output voltage from the battery management system is measured and cross-verified with a digital gauge, ensuring a close match with the system's internal reading.